Assalamualaikum and good afternoon. So today again we'll be looking at on how to this is actually a new example that how to solve or find the velocity of certain parts using graphical method. So in this case we are talking for this example I'll be using a shearing mechanism where in this case it is as this figure 6.23 according to the problem, the question that I uploaded to uLearn. So in this case, we have a crank that will be rotating at 100 RPM, and this will rotate clockwise. And with that, you will drive also the connecting link, and also will drive the blade. And this blade is being fixed to travel only vertically up and down. So we need to find the relative. We need to know the velocity of the blade as the crank rotates clockwise at 100 RPM. Okay, first we need to solve for the velocities. Okay. Um, so in this case, the velocity is being rotated at 100 RPM. So omega is equals to 100 RPM. But of course, we need to convert it in terms of radian per second. Therefore, we have to times by 25 over 60. So basically, the resultant angular velocity is 10.47 radian per second. And then from there, so we already have the angular velocity in terms of radian per second. Now we need to find the velocity at this point. Okay, so the velocity should be always omega r. So let's say this is A, B, C, right? A, B, C. So VB, so in this case, this is VB, velocity at B. Okay, VB is equals to omega r, which is equals to 10.47 times 0.75 inch. So equals to 7.85 inch per second. So this is the velocity of VB, and this VB will be acting at some angle. In this case, we have to solve it. Okay, it will be in this form. This is 40 degrees, right? It's 40 degrees. This is 90 degrees. So in this case, this is 40 degrees. Sorry, 50 degrees. 50 degrees. So it is actually the velocity is 7.85 inch per second at 50 degrees to the horizontal. Okay, now let's go and basically draw the first is the kinetic diagram, and then we have to draw the velocity diagram. Okay, let's start with this. So first is that we need to draw point A and point B at 40 degrees with the length of 0.75 inch. Okay. So let's say the point A is here. This is A. I have to measure 40 degrees to the horizontal. Try to be as accurate as possible. So 40 degrees downward, 10, 20, 30, 40. 40 degrees. Then we have to draw according to the inch, which is 0.75. Okay, 40 degrees, 0.75, 0.5, 0.6, 0.7, 0.75. maybe somewhere here. Yep. 0, 5. Sorry. 1, 2, 3, 4. Somewhere here. All right. This is 0.75 inch. Next is to actually draw this line. Okay, and from there then we can find this the position of BC. Okay, and we have to draw 0.5 inch to this. Okay, the best thing is we have to draw according to the scale. Okay, we have our set of 0.5 inch. This case is somewhere here, 0.5 inch. Then we have to draw straight down. Have to use this scale here. Sorry, protractor here. Just 20 degrees. Okay, straight line there. Then we have to draw 4 inch. Okay. Now the length of the connecting arm is 4 inches. Okay, 4 inches. Sorry, 4 inches. So we measure 4 inches from here. With that, okay, that's 4 inches. So that's point A, this is point B, and then this is point C. Okay, then we know that VB is in this direction, which is 50 degrees to the horizontal. Okay, in this direction, VB. Let's just draw this. This VB. Then we have VCB, which is this is just estimate. VCB. Then we have VC either goes up or down. In this case, we think it is going upward. VC. Okay. Just need to confirm whether this is really at right angle or not. Oh no, it was not. It was not really at right angle. So okay, from here it's 90 degrees to here. So now we need to find the angle of this. Just to find the angle here, it will be equal to 10, 11, 12, 13, 14, 15, 16, 17. This is 17 degrees. Oh, sorry. 17 degrees. So now we need to draw the velocity vector. Okay, VB in this case is equals to 7.85 inch per second at 50 degrees, which is basically like this, and VCB at 70 degrees. Actually, we don't know yet which one is the right direction. So from there, we know that basically VC equals to VB plus VCB, right? So we draw VB and VC at one point. So let's say we start from here, from this point. So at 50 degrees, is over here. So we draw 7.85. It's too long, we have to convert the unit, make it smaller. 7.85. So what is this? Okay, up to here. 7.85, and we have BC, straight line, and then we have VCB, which is at 17 degrees to horizontal. So now to measure this from this point, (17 degrees). 1 second, 17, 10, 17. Right. Once we draw this line, okay, basically this is this is VB, this is VCB, and this one is VC. So by measuring, let's measure VCB first. So VCB is equals to 1, 2, 3, 4, 5, 5.4. Okay, this measurement is in centimeter, but actually we have already scaled down that 1 cm equals to 1 inch. Yeah, it'll be easier. So VC is equals to we measure here to here. So 7.6 inch per second. So this is basically the answer that we're looking for. Well, it will definitely not be as accurate as you want to be, but at least you get the idea how much is the velocity for VC and so on. Okay, thank you very much. That will be it for velocity analysis. Thank you.